Welcome to Unit 6 of the main course Remote Update of Programs and Functionalities. Today we are going to talk about PLC updates and upgrades. So what will be the content of this unit? We'll start with the difference between updates and upgrades. Next we're going to talk about the reasons why we should do updates and upgrades. And finally we'll talk about the minimization of the interruption of the program, which is especially important on PLCs when they control machines that should not be stopped. So what are the learning outcomes? Basically, you should understand why there is updates and upgrades, especially what is the difference between them. You should be able to name reasons for changes, and you should be able to at least a little bit predict effort and downtime for different types of updates and upgrades. So let's start with the difference. Why is there a difference? They sound pretty similar. Nevertheless, there's a difference in what they change on our system. So an update normally just improves the system. So there's existing stuff on the machine and it gets improved by removing bugs, by enhancing security or adding slight functionality changes which improve maybe the user interface or just help to run the processes a little bit smoother on a PLC. So there's no major change. This is different when we talk about upgrades. So they really extend the system with some new functionality. As an example that most of you will know, Microsoft Windows. If you change from Windows 11 Home Edition to Windows 11 Pro Edition, this is an upgrade because it includes a lot of new functionalities and a lot of extras that are not available in the Home Edition. The same is true for changing the Windows version completely, so changing from Windows 10 to 11, for example. So there's new functionalities introduced and the whole operating system changes, and therefore also mostly, at least with Windows, the user interface changes. On the opposite, applying just a patch or a service release on Windows is an update. So the functionality of the system basically stays the same, but it's more stable or more secure. And just some minor changes in the user interface or the functionality are also included. Sometimes not only positive stuff, but also compatibility issues are solved or are introduced because manufacturers of other drivers haven't been able to support this new patch of Windows. Nevertheless, it's always a good idea to install such patches because of security reasons. And why do we need to do that, especially on a PLC? So what can happen on a PLC? So the hardware can be broken or defective for any reasons. You know, a lightning strikes somewhere near your place and the electricity ruins the hardware, or somebody crashes the hardware for any reasons because somebody in production is doing something that he or she shouldn't do, or somebody's working with electricity and introduces a bug. So the hardware could be broken for such reasons. It also could happen that the current hardware or firmware doesn't support some functionalities, which means we want to connect, for example, to another system which was not connected before, and when we want to do that, we find out that the hardware does not support this functionality. Same is true for additional bus systems. If we want to add new bus systems and they're not supported by the current hardware, we of course have to change the hardware. And very often it happens that computing power is not sufficient on the current system. That's why we have to change it. And finally, we should also consider cloning of the system, which means that we have one system that is already running. We rebuild the same machine, and therefore we want to clone the program, including, of course, the hardware. So hardware changes on PLCs can consider different parts of the PLC. It could be the CPU, especially hardware. It could include the CPU firmware, but also include the CPU's operating system. This is something that you should consider, which is necessary to change and what will happen then. But you also can change I/O modules. On one hand, the hardware, on the other hand, as well, the firmware. So most PLC manufacturers have more or less intelligent modules, which means that they have some embedded system on them, some microcontroller that controls the I/Os. And these controls normally also have some kind of firmware, and this firmware can be updated as well. And then a major issue is firmware and operating system changes. Why do we do that? If the hardware has changed, this is quite obvious, but it also can happen that the programming environment was updated, now supporting different functionalities that have not been available on the previous operating system. For example, when you consider Siemens, the switch to the TIA portal, totally integrated automation portal, introduced new functionalities to remote setup, remote control, or cloud connect different PLCs, which means that they, of course, have to support this mechanism as well. And then, of course, there's security issues. If there's some bugs or holes found in the current operating system, it's quite obvious that this should be fixed in some way. And again, there's optimization reasons, which also are a reason to change the operating system. And finally, of course, and this is what we will experience most, is user program changes. So when we add functionality or add speed, this is something, especially in industry, that is very important. You have a running machine and you can increase the throughput of the machine by just changing slight things. And you'll be the hero of the production, because production that runs faster on the same hardware just by changing software, optimizing something, this of course is very, very cool and great, and will increase the throughput of the system and help to save money. Then of course there's always some things like bug fixes, so issues that you have to fix for some reason. Sometimes just because they were annoying, sometimes because they prevent the system from operating properly. Improvements in speed and operation, I've already mentioned. Also, it can happen that you add some hardware, extra sensors or extra actuators that also improve the functionality of the system. Then something that happens more and more is communication to other systems. So connection to some cloud where production numbers are reported automatically, statistics are reported automatically. So giving the background to a big data approach where you can take all this data later on a server where the data is uploaded automatically, and then you can check for optimization potential, which is something that helps improving production, but on the other hand increases complexity as well. And of course, with a lot of machines you have a user interface, some kind of human-machine interface, and this also can be improved by adding more values to display, by giving more interaction with the system and similar things. And the main issue is, how can we minimize the interruption of the PLC operation? So ideally, we do not stop the machine, but we continue production while still being able to upload software. And this depends on certain aspects. So anyway, there will be a slight interruption. The question is, do we have to stop the system totally, or are we able to continue rather immediately? Big issues, big changes normally should be planned in advance, which means if there's some holidays where all the machines are serviced, then this will be the perfect time to install all the updates as well. Because everybody's aware that something has changed or will change. You can do a lot of tests after you entered the new software. And if there are severe problems, you still can do some rollback which means that you replace the new version again with the old version to be able to continue production like before. So if you change the hardware, of course, you have to turn off the system. If the hardware is already crashed, for some reason, it's quite obvious that it is already turned off. Nevertheless, the downtime then will depend on the worker skill. So if the parts are available, then you can change them. So ideally, the hardware is already on stock. In automotive industry, you are obliged to use only a few types of PLCs exactly for that reason. They are kept in stock, and if there is some hardware failure, they just replace the PLC or the I/O modules. You take out the memory card, change the CPU, and insert the old memory card in the new CPU and continue working. So the downtime will be minimized, and this is essential. If you think of automotive production, typically a car is produced every minute, up to 3 minutes, depending on the number of cars produced by this plant. Which means that if you have a downtime of 2 minutes, 2 cars could not have been built, so there's a loss of the price of 2 cars that otherwise could have been produced. With operating systems, system changes, this is even worse. Because you do not change the hardware, you change the system on the hardware, which means that you have to do some installation, and this installation normally takes some time. And after you power up and start up the system again, you will have to test the functionality. And if you have safety PLCs, which is quite likely nowadays, so that the PLC also includes all the safety mechanisms, then you have to consider that also updating this, or at least reconnecting this, will also take some time. And if you update an operating system, it's quite likely that you will have to set some parameters for communication, and this could mean that also some other partners have to upgrade to a new operation system as well. And when you change I/Os and the program architecture, so bigger changes in your user program, it's quite likely that you also have to power down the system, or at least, not electrically, but at least shut down and restart the system. And again, you need some downtime for testing, downtime of the machine, of course, for testing, and again, you have to consider the safety PLC stuff. The reason for this is that internal variables, if you add some or change them significantly, the whole program has to be replaced. So you cannot do an in-place exchange very easily, because if variables change and their values change, and also maybe their type change, it can happen that the program would crash if you just download it. And normally it's better to have a machine turned off properly and started again. Is better than to crash the machine because of some program failure. And when you just change the program, so introduce a new algorithm, so just some code changes without changing variables, without changing the architecture, the modules, the program components, normally it's possible to do some online change also. You could either do a full download. This is something that most of the PLC manufacturers suggest, because then it's clear that a system is started from scratch, which means that all the variables are initialized properly. But if you just want to do some minor changes in a running system, you could also go with the online change, which means that parts of the program are replaced by new blocks instantly, and in the next cycle, already the new program is run, which means it's just switching between 2 cycles. So this can have a big impact on your machine if your stuff is not thoroughly tested. And in the next unit, we're going to see how online changes and downloads have to be conducted on different types of PLCs. Thank you and see you again in the next unit.